Projectile motion. A projectile is an object that is projected or launched into the air. For example, kicking, hitting, or throwing. After that, it moves only under the influence of gravitational force. Gravitational acceleration always acts downward on Earth. On Earth, the gravitational acceleration is 9,8 meters per second squared downward. The equation G is equal to capital Gm over r squared, where G represents the gravitational acceleration measured in meters per second squared, capital G represents the universal gravitational constant, capital M represents the mass of Earth, which is measured in kilograms, and r represents the radius of the Earth in meters. Therefore, all objects fall with the same acceleration, and G does not depend on the mass of the object. For example, in a vacuum, such as a glass tube, a coin and a piece of cloth of the same size will reach the bottom at the same time when dropped from the same height. Terminal velocity. When a skydiver is in air, there are two forces acting on him. Firstly, his weight, which is downward, and air resistance, which is upward. Terminal velocity occurs when the upward air resistance and downward gravitational force are equal in magnitude. Therefore, the object falls at a constant velocity. Free fall. An object is in free fall when gravitational force is the only force that acts on the object. Let us look at the equations of motion. Previously, we used these equations of motion, but when we work with vertical projectile motion, we can replace the delta x with delta y, and we can replace the a with g. Direction is very important when we're working with projectile motion. When an object moves upward, its velocity is upward, and its change in velocity would be slowing down, and its gravitational acceleration would be downward. For example, when we throw a stone into the air. When an object moves downward, for example, when we drop a stone, its velocity is downward, its change in velocity, it speeds up, and its gravitational acceleration would also be downward. There are few important rules to keep in mind when doing calculations. Always choose a direction as positive. For example, an arrow pointing upward is positive and an arrow pointing downward is negative. Or you could take an arrow pointing downward as positive. Always draw a diagram. The time taken to reach the maximum height is equal to the time taken to return to its point. For example, when a stone is thrown upward and it is caught, it takes 2 seconds to reach the top, and then when it returns to the thrower's hand, it takes another 2 seconds. This is called time symmetry. And the velocity at the maximum height is always going to be 0, as in the diagram. Let us look at a few other examples. A ball is dropped from a building which is 50 meters high as shown. Calculate the ball's velocity just before it hits the ground. So if a ball is dropped, its initial velocity is going to be 0. We are given that the building is 50 meters high, and we know gravitational acceleration is 9,8 meters per second squared. We are going to take the direction downward as being positive. So we can use the equation Vf squared is equal to Vi squared plus 2g delta y. We want to solve for Vf. So your initial velocity is 0 squared plus 2 into, because downward direction is taken as positive, we use a positive value for g, which is 9,8 multiplied by 50. We get Vf squared is equal to 980, and we find the square root of 980. It gives us 31.30 meters per second downward. Let us look at another example. Right. A ball is projected vertically upward at 20 meters per second as shown below. Calculate the maximum height that the ball will reach. Ignore the effects of air resistance. So the ball is thrown up with an initial velocity of 20 meters per second. When it reaches its maximum height, its velocity is going to be 0. Because the ball is thrown upward, we're going to take upward direction as being positive. So we have the initial velocity, we have g's value, and we have the final velocity, which is 0. So Vf squared is equal to Vi squared plus 2g delta y. your final velocity is 0 squared is equal to 20 squared plus 2 into this time. We use g's value as a negative value because we have taken upward direction as positive. If we multiply the 200 out, we're going to get negative 400 is equal to negative 19,6 times delta y. And if we solve for delta y, we would get the answer as given. Right. The last example that we are going to go through, right? So a stone is dropped off a building and it strikes the water below 5 seconds later. So the stone is dropped, so its initial velocity is 0, and after 5 seconds, which is delta t, it would reach the water below. They are asking us to calculate the vertical distance that the stone falls. So we need to find delta y. We can use the equation delta y is equal to vi delta t plus half g delta t squared. We are going to take downward direction as positive as the stone falls downward. Right, your initial velocity is 0. The time would be 5 seconds plus half into, because downward direction is taken as positive, we use a positive value for 9,8 and you multiply it by 5 squared, which is the time. Then we solve for delta y, which is 122,5 meters. For question B, the velocity with which the stone hits the water. So we're actually looking for VF. Keeping in mind what information we do have, we can use the equation VF is equal to VI plus G delta T. Your initial velocity is the 0 plus, because we're still going downward, we use a positive 9,8 and multiply it by the time, which is 5. Therefore, your final velocity would equal to 47.5 meters per second downward. Don't forget that if it's any vector quantity, the direction must be indicated.